What is always the first step, no matter what? When graphing functions, we have a first step always. What is it?
Figuring out the domain.
Excellent. Please, thank you very much. Please, thank you, thank you, thank you. Awesome. Thank you. So I recommend this method. Always change this into the interval notation. This is just the point. We cannot do anything to it. And change this into the interval notation. Can anyone give us the interval notation for x less than 0 and for x greater than 0?
Negative infinity 0
Very good. Awesome.
and 0 infinity.
Very good. So now, we identify the domain. Everything between negative infinity and 0. 0. And everything between 0 and infinity. Can anyone give us an idea about the domain, which will not always be that situation? But what is the domain for this function?
Would it be negative infinity 0 and then u?
So we have everything to the left of 0, we have 0, and we have everything to the right of 0. In other words, we have everything.
Negative infinity to infinity.
That's it. It's not a mistake to write it as you said it, but it's not, there is no need. We have everything to the left of 0, everything to the right of 0, and 0. So we write this condensed. Is that okay, everyone? Now in step 2, I start preparing the table. Negative infinity to infinity is the domain. So that's step 2 always. See, 0 is a very important point. So we have a parenthesis, so 0 is right in the middle. Parenthesis to the left, parenthesis to the right, and a number in the middle. When x is 0, y is 4. But a parenthesis to the left and a parenthesis to the right. All these are right under 0. Now, I would write that between negative infinity and 0, I have to use negative x. Between 0 and infinity, I have to use x plus 2. Why do I put them here? Just because these may not be in the correct order, and I don't want to have to go back and look and make a mistake. I prefer to see the functions up here. There is no need for this, which is a point. I already have it. Now, to the left, I have to pick some values, because this is, what type of function is this? What type of function is this? What are these functions? Can anyone identify negative x and x plus 2? What type of functions are they?
Is it linear?
Yes. Linear. Linear. Perfect. So I need 2 points here and 2 points here. I'm going to use negative 1 and 0. When I plug in negative 1, can anyone tell us what y value we get when we plug in negative 1 here? Perfect. I know I'm not allowed to plug in 0, but we'll see in a moment. So when we plug in 0 here, what do we get? Inside the parenthesis, what do we get?
Zero.
Yes. Perfect. So this will be an open point. This will be a full point. So now let's plug in 0 here and also 1. Plug in 0 and tell me what you get.
2.
Very good. Please plug in 1 and tell me what you get.
3.
Excellent. Please understand that these are 3 separate branches. I'm going to use red for the first one, black for the middle one, and I'm going to use whatever this is for the right one. Do you have to do this? No. I'm only trying to make a point. And the point I'm trying to make is that if you graph them overlapping, that will be incorrect. That's all I'm trying to make. That's the only point I'm trying to make. Negative 1, 1. When x is negative 1, y is 1. 0, 0. But it's an open point because I'm not allowed, it's not 0 is not here. I'm not allowed to plug in 0. But then why do I do that? Because then I will have to plug in negative 0.0000000000000001. I don't want to do that. I will plug in 0 and I will leave it open. It's a line. That is done. I put this aside. If I connect to the rest, they will be incorrect. 0, 4. And this is a full point. Done. Put it aside. And now the last one, 0, 2, which has to be an open point. Otherwise, this would not be a function. And 1, 3. And this is the line. Notice that red and black and whatever brownish this is, I'm not good with colors, names of colors, I would say. As you see, there is no overlap. By the vertical line test, every vertical line crosses the graph in one point only. Any questions on this problem, please? There is no... Yes, go ahead.
I keep getting stuck on the table. Like, so, talking about the numbers being in order, I guess. At the top, the domain is in order, negative infinity, 1, 0, so on and so on. But at the bottom, the numbers aren't in order. So, I think I'm just kind of messing them up.
These numbers depend on the function. You plug in negative 1, you have to write 1. You plug in 0, you have to write 0. You plug in 0, you have to write 4. You plug in 0, you have to write 2. You plug in 1, you have to write 3. It has nothing to do with anything.
I have a question.
Hold on just 1 second. Don't forget your question. So the ordered pairs are negative 1, 1. The ordered pair 0, 0, 0, 4, 0, 2, 1, 3. You have to graph what you get. This may or may not be in any order. We don't care. All we care about is we are plugging in values to the left of 0 in this function and to the right of 0 in this function. These cannot be or should not be or maybe, we don't care if they are in a particular order or not. We have to plot this. X, Y, X, Y, X, Y, X, Y, X, Y. Is that okay? Before we move on to the next question, is that okay? Anyone? Is it better now?
Yeah.
Good. Next question. There was something else I interrupted you. Forgive me. I just wanted to make sure that this was clear.
Does our table have to look exactly like that, or as long as there's a table showing the correct numbers, will we get?
So if you use a different method, you may or may not. This is a very easy method. But if you don't use it, you may not be able to. You may not. I don't know for sure. But you may not be able to identify the correct points and the open points. This table is specifically made to identify correctly the full points and the open points. Other methods with two separate tables may not give you what you are looking for. I don't recommend them. Any questions? Does that answer your question?
Yes.
Good. Other questions for me? Other questions? Okay, then well, let's continue with R.3. We already started. I didn't tell you. Domain and range. Okay. I would like us to share, I would like myself to share my screen. And let's take a look and try to identify domain and range. Which function or graphs you would like to start with in identifying domain and range. I did print out last time, I was hoping that we will get there, but if I stop sharing, I have a printout from this page. So let me know if you'd like to choose from here. 23, 24, 25, 26, 27. Oh, these are gone. So from these four. Can anyone,
Let's choose 23.
which one? 23?
23.
Perfect. Can you see? Is it big enough for you?
It's a decent size.
Is that okay?
Yeah, I'm okay.
Okay. So see, these points are not connected. Is this a function? Yes, by the vertical line test. Each vertical line crosses the graph of the function in only one point. So function, yes. What will be the domain for 23? -5, -3. So because I'm identifying the x values, I cannot use brackets, I cannot use parentheses. I have to list them. -5, comma, -3, comma, 1, comma, 2, comma, 3, comma, 4, comma, 5. This is it. What about the range? In the same way, but on the horizontal. -3, +2, +4, +5. -3, +2, +4, +5. So -3, 2, 4, comma, and 5. I cannot use parentheses because the points are not connected. I cannot use brackets for the same reason. I have to list the elements. Now, for example, if we choose 25, it's a different story. 25, the domain is from the leftmost point till the rightmost point. Because these are full points, I will be using brackets. Because the function is, we say, continuous, it's connected, all points are connected, I will say between -2 and 4. How do I determine the range? Same thing. From the lowest y value till the highest y value. All points exist, including these, so I will have the range. So this was for 23, and this is for 25. I will have the range between -3 and 3 with brackets. What if I have something like this? Here I will have a parenthesis. So if this is between, let's say we're talking about the domain, between -2 and 5, then the domain will be parenthesis -2, 5 bracket. Why 5 bracket? Because the point exists, as we used it in the table. Why parenthesis? Well, because the point does not exist. That's how we identify domain and range. Any questions? Any questions? Of course, I'm going to post this for you. Any questions on this? Now, here is a problem, 45. 45. We have g of x equals the square root of 4 plus 5x. 45. The square root of 4 plus 5x. We're asked to find the domain of this function. How do I find the domain of this function? What do I have to write first before I find the domain? Can anyone tell us what to write? Yes, I'm ready.
You want to set it equal to 0 and then just find what can't be negative.
So how do I write it?
So 4 plus 5x equals 0.
So let's go back to our notes from a few minutes ago. Even index, yes, even index.
So it would be greater than or equal to 0.
Excellent, thank you. Move forward to the other side. Divide both sides by 5. Perfect. How do I write the domain? Can anyone translate this inequality into an interval notation?
Negative 4 over 5 less than or equal to x.
The interval notation.
I have a question.
Yes.
How do you go from the function g of x, right? How do you go from the function to fraction? Like how do I know what fraction is the right answer?
So in order to solve this inequality, I have to separate the terms with variable from the terms without the variable. This has its positive. I have to move it to the other side. Or you can say you subtract if that's what you want. Same thing. And then you have to divide both sides by 5 because you are trying to solve for x. X gives us the domain.
Okay, thank you very much.
Thank you. So we move through. Yes, go ahead.
So the domain will be negative 4 over 5 infinity.
Infinity is always parenthesis because it's a symbol. But what is the symbol that I have to put here?
That will be the closed off.
Yes. So what does that is represented? The equal symbol is represented by, we have two symbols, a parenthesis or a bracket. Which of these two? Yes. Awesome. So this is exactly what we just did. X minus 3 greater than or equal to 0. We move 3 to the other side, and that's what we wrote. From 3 to infinity. So here we have x greater than or equal to negative 4/5 from negative 4/5 to infinity. That's the domain. Any questions? What about the domain? What about the domain of such a function? X squared minus 2x plus 1. What will you say? 47. G of x, x squared minus 2x plus 1. What would you say? What is the domain of this function?